All right, at the very last of the videos, I was talking about we're looking for the rate here, and then the camera stopped taping, so here I am finishing up the rest of it. So the is going to be our equal sign, so 180 equals what percent is going to be our R for our rate of 2,000, so multiplied by 2,000. The one thing you do have to remember with doing rates is that we get the decimal out of this this equation, and we want the answer to be in a percent. So we have to make sure we do one additional step once we've solved for R. So divide both sides by 2,000. And you should be getting something that is less than, well, never mind. It might be larger than 1, but most of the time it's going to be less than 1 on this in this situation. Okay, so 180 divided by 2,000, and we get 0.09. So for Alex especially, read carefully because it's most likely going to ask for percent. You'll notice that it says percent here. What percent? So this is the rate as a decimal, so we do need to change that to 9% as the rate there. Okay, I'm going to pause that for a second so I can flip pages. Okay, we are on the top of page 36, and for this top one, here you can see that we are getting into the more complex of the application problems where there's a context happening with the situation and all that. And this is where it's not as easy to directly translate into an equation. And it may be easier to think about it in terms of the percent proportion, because if we can find that proportional relationship, it makes it easier to know that we are putting the numbers in the right places. So let's read through this and then try to identify what we have and what we are looking to find. So in tests of a new anti-inflammatory drug, it was found that 47 subjects experienced nausea. Okay, so we had 47 subjects, nausea. And this is what I would do if I was approaching this for the first time, is I'm going to basically kind of take notes on what's in the problem. If this represents 4% of the sample, how many subjects were tested? Okay, so this 47 subjects that have nausea is the same as 4% of the total sample. And we want to know how many people were tested. So we're looking for what is that total sample in here. So if I think about it in terms of rate, amount, and base, so our rate that we are given is 4% of that sample, of the total sample, pardon me, and the 47 subjects are both talking about the same idea. And that's what's crucial with talking about this, is that this rate and this amount have to be talking about the same concept, but one as a percent and the other as whatever the label is for our particular example that we're looking at. For this one, it's actually people. So that 47 subjects is 4% of the whole thing. So if these two are talking about the same thing, then we're all set because we don't have to do any subtractions or anything. And we can go right ahead and putting it into the formula. So amount is rate times base. So 47 subjects is the rate. Remember, you will need to use 0.04 in this formula times the base. And then we divide. Now, if this is only 4% of the sample, then we should get something larger than 47. If you don't get something larger than 47, then you accidentally did something with your calculator or something along those lines. So when I do this divided by 0.4, I'm getting B is 1,175. And remember that this is subjects in the sample. So some sort of label on there so that it's clear that you know what you found and you can explain that information to other people. Okay. And this next one is going more towards percent and finding percents. And we can do this one slightly differently. We're still using this same idea that the amount equals the rate times the base. But we're probably going to use the format that the amount divided by the base is the rate. So this form of the formula will be a little bit more helpful in this situation. And that's because I've scanned through and I'm looking for percents here. So the first thing is we need to figure out how many total employees are. Now this table, and I'm going to have to kind of slide up and down here a little bit with this one. So we've got the number of days missed is in this column from 0 to 7. And then the number of employees who have missed that many days in the past year. So it's a 1-year absentee record for a business. So people can't be gone a different number of days. They're either gone 0, 1, 2, 3, 4, 5, or 6 days. They can't fall into more than one of these categories. That means that nobody is double counted over here in the employee side of the column. So I can just add those up and get the total amount of employees. So we would say 4 plus 2 plus 14 plus 10 plus 16 plus 18 plus 10 plus 6. And that's going to give us a total of 80 employees. And that is important to know because these percents we're going to find them by looking at how many people fall into a certain category divided by the total number of employees that exist in the company. So going back up here, so there's 80 employees. And then what percent missed exactly 3 days of work? And you're really going to have to make sure that you are reading carefully here, because exactly 3 days of work means I only am looking at one row of this table, because 3 days of work is this one here. Okay. So I am looking at that, meaning that 10 employees missed 3 days. Now we want the percent of that. So instead of talking about it as 10 employees, we want to talk about it in terms of the number of those out of the total number of employees. So our rate in this case is going to be that 10 employees divided by the 80 employees total that are in this company. And then you find out that that is going to be, should be 0.125. Let's see here. Yeah. Okay, so R here is 0.125. Now remember, this is still a decimal. So we need to move the decimal point 2 places to the right to make a percent. So 12.5% would be the answer that we are looking for. And that's going to mean, so back up here at the question itself, 12.5% missed exactly 3 days. Now, part C, we've got to do a little bit more reading between the lines there. There's some math terminology happening in there. So what percent missed between 1 and 5 days inclusively? So if we think about between 1 and 5 days, so people could miss 1 day, they could miss 2 days, they could miss 3 days, they could miss 4 days, they could miss 5 days. And the inclusively says that we include the 1 and the 5. If it was exclusively, then we would only want what is strictly between 1 and 5. So inclusive, we include those endpoints. Exclusive, we don't. So for this one, we do. So we actually need to look at 5 rows of this table in order to figure out how many people we're missing. So I'm looking at the row 1, row 2, row 3, row 4, and row 5, and then the corresponding employees. So I have 2 employees there, 14 here, 10 here, 16 here, and 18, and the 5th row. And I would need to add those up. Plus 10, plus 16, plus 18. And that is going to give me 60 people missed 1, 2, 3, 4, or 5 days in that year. But we want it as a percent. So that's when we need to look at this format again, and we will use our amount over base equals the rate. So the amount of people that missed is 60 people over the total of 80 people in the company. And so 60 divided by 80 is going to give us a rate of 0.75. And don't forget that this is still a decimal, so we need to move that decimal point 2 places to the right to get the percent. So the answer then is 75% of employees missed 1, 2, 3, 4, or 5 days. Now, the amount of labeling that you have to do on ALEKS will be slightly different depending on the problems that you're looking at. But when we were doing written things that I'm going to be looking at, like on quizzes, please make sure that you are writing out so that I know you know what you're talking about. Okay, I'm going to pause for a moment and move on to page 37. All right, so I've flipped over, so I'm on the top of page 37, and I've highlighted in yellow the ones that we're going to look at together on here, and then I will put up a PDF with everything in it so that you can do some of these examples later, maybe to get ready before the test, and have a place where you can look and see if you did them correctly with all the work shown. So we're going to do part A in this one, and so we've got 3 columns here, total sales, the commission rate, and the amount of commission. So this one we are looking at, we have total sales are $540. The commission rate is 15%, and we want the commission amount, which means we are going to want dollars that represent that 15% of the total sales. So we have an amount, we have a rate, and we have a base. So we can pretty much translate this one. We can lay this one out and plug those values in there directly. So amount equals rate times base. And remember that the amount and the rate need to talk about the same thing. And they are talking about the same thing here, right? 15% is specifically the commission rate. That will translate to the commission amount, which is the thing that I'm looking to find. So it's okay that this one is unknown because I have the rate that refers to it. So I can figure out how to talk about commission in terms of dollars instead of just in terms of percent. Don't forget that your rate will have to become a decimal, so it'll be 0.15. And then we're multiplying by total sales, which is $540. So we multiply those together, and we get 81. And then don't forget to say that it's $81 is the commission amount, something like that. Those are going to be pretty straightforward. They just have the 3 pieces there. So you're looking at your total sales is going to be your base, because your base is talking about a total of some sort. And then your commission rate will be your percentage. used as a decimal, and then the amount of your commission would be that portion that